In this video I will show you a small program for the ESP32. It's Arduino-like microprocessor where we are able to do the following stuff. We have here an impulse, a small impulse, and the ESP32 is a very fast microprocessor. So the one impulse is about 50 nanoseconds, and like this one, now you see 250, so this is 5 nanoseconds. And what I have done in this case is I have here a small program written in the Arduino interface. Therefore, you also first have to go to the board manager, and inside the board manager you will find somewhere the ESP module. And inside there I said, okay, I'm using the pins on the front side, those pins on the front side. So this is the ESP32 develop kit, NodeMCU. I think that's the correct word for it. And I've connected it to the USB cable. So the USB cable supports it with 5 volts, and those 5 volts are also in here. We have this 5 volts there. These are the 5 volts, and the 5 volts go here to a voltage regulator, and they support the system by 3.3 volts. So the microprocessor is running by 3.3 volts. But anyways, we may use those GPIO. So these red ones are the GPIOs. So I connected now. Those 5 volts are also on here. I connected it to my breadboard, and then I'm able now to use those input pins to change the width of this signal. So in here we have the width by 250 nanoseconds, and inside there, this is my pulse width, and I also, this is 1 second or something like this. I want a shoot 1 second, and I want to modify the pulse width for this point. So this should be about 50 nanoseconds to enlarge it to, let's say, 1 microsecond. And therefore we have here our pin selection, GPIO. GPIO means they are selected as an in, and these are those pins. The pins are in the pin layout. And now what I'm able to do now is, when I change my cable to another position, you see this one shrinks down. So when I go to this position, then you see the system is changing. So this is 2 impulses. Then when I change it to another position, you will always see on the monitor how it changes. And so we have a simple modification of the impulse length of a system with a microprocessor. So this is about, the small device costs 10 euros or USD dollars. So no, three about, let's say, between 5 and 10 euros. This device is very small and useful. The processor is very fast, and you have the ability to switch the system now to an variable impulse length. And the code is in here. I'm short for a moment explaining the code. So what I did is I said, okay, here's my input pins. So I said, okay, here are different pins. and on my processor, these are the pins, and I've connected it to the output is pin 15. Those are difficult pins, and from 4 to before ground, I said, okay, this is 1, 2, 3, 4, 5, 6 times the length. So this is the length adjustment. And I said, okay, here my in 7, 8, 9, 10. That's the description of my board panel in here. So this is there's where the small number or line, like a line number is. I said, okay, this is a pin on the setup. That's the definition at the beginning, the Arduino program. And I said, okay, this is the pin mode. So these are all input pins, and the output is the out pin. Out pin is 15. And then I said, okay, my dear program, here's the loop where inside this one, after the setup, that setup is processor starts or boots. It's setting up all those values, and then it loops all the time around. So I'm reading at the beginning of a loop which cable is connected. So I read digital read 7 if the value is higher than 0. So this is on or high. Then it's cycled 3 times. So this means when we have here 5 volts, the 5 volts go to the input pin, which is normally 3.3 volt. So the input is no problem. You will have on this point input the value in digital read in goes to in. So this is normally 0 if nothing is in there, so it's a low. And it will be high if it's larger than 0. It cycles the high cycles to 3. So I'm setting up those cycles. And finally, I will say, there's the for loop. I would say for all those cycles which we have output pin from the high cycle 0 for this loop I high is smaller than high cycles. It should increase up. So this is a for loop. And after this, when it's pushing always, when it sets very fast as the on, then after this I will say, okay, say to digital write low. And I'm doing this by this low, by this small cycle, because one of those cycles is about 50 nanoseconds. So you cannot say a delay with 50 nanoseconds. And after all, I would say make a delay, a definite microsecond delay of one. Smallest value is 1 microsecond. So this is my program, and I will set up that program to my website, and you will be able to create a modification of that point.